We have moved a little bit forward from Megaregions of the United States, part 1. So this is where to find them and what to do with them. So I'll just start and then switch over to Garrett. This is our Megaregions of the US map. And given Garrett's deep knowledge of US regional history and all sorts of other things, misspent youth perhaps, we gave them kind of descriptive names. We do have a number of different names based on the original city, but when we called them New York or Chicago, people just think it's a city and it's a larger commuting labour market area, which is not what a mega region is in this context. It's kind of a container. But when we show you this, and when you show people this, they see hard lines on maps and they look at it. They get mad about the names obviously, but they look at it and they see lines, and the first thing they do is say, you've just got this wrong. But actually, when we did a Q&A online on Reddit, a lot of people said, you've got this right. But it wasn't us that did it anyways. That's the point. Hard lines on map give a somewhat misleading impression. So we'll get to that and how these are fuzzy and fluid. But that was the actual boundaries that we came up with in our 2016 paper. Like I said, I have liked this and admired this for a long time. Our approach was different, obviously, but what I thought would be interesting to do, just to recap, to show this again, and I'm assuming others will, how does that map on to what we did? So again, until this week, we hadn't actually looked at that. So that was the original, that's the America 2050, and it's a combination. Now, it's quite nice, we think, that it's a different geography, but it is quite nice where you have our 4 megaregions here, how the Piedmont Atlantic fits within that. So we're trying to understand how this maps on to different things. So you do get the boundaries and demarcation in the places where you might expect it. Of course, our map is complete in the sense that it covers the whole of the lower 48. So that was quite interesting. So some of this thinking is, how do these things come together and do they make sense? Obviously, the Texas Triangle, you can see, is split between 3 of our megaregions, but it's nice that it fits within 3, given that it's a triangle. So this is somewhat of a validation, but it also shows how these two things can complement each other in different approaches. So we very much are aware that our approach is one specific approach to one type of data when we're thinking about megaregions, and it is transport focused.
What we use is a relatively new method that's called community detection within complex networks. And what that does essentially is a algorithmic approach where you take a network of things that are interacted in some way, and you ask a computer to divide that set into relatively self-contained portions. So this is a obviously highly simplified illustration of that. We've got about a dozen points. In our context, that would be census tracts. And you've got a weighted series of relationships between those points. In our case, those are commuter flows. And we're using census commuter flows that include all work-home relationships, regardless of if those are a 9-to-5 standard, driving commute in that sense, or some sort of the many different types of home-to-work relationships that are captured in that census definition. So in a network structure like this, you can see everything is connected to everything else. There's no way that you can perfectly divide this up the way you can divide, for instance, a watershed into identifiable cells that don't overlap. That anywhere you cut this up, you're going to be cutting some connections. So you can see here, the reason I point this out is that the spatiality of this network actually does not matter. So if I move this point from here to there, even though it's now physically closer in kind of geographic space to that group, these two sets are identical from the point of view of the computer. All they know is where the points exist and they're related to each other in some weighted way. And when you run this community detection algorithm, you get something that looks like this. The computer thinks, how am I going to divide this set up in a way that severs the least number of threads? That's kind of one metaphor that you could use to think about this process. Again, in this very simplified illustration, you've got 2 communities, an orange community over here, a blue community on the right. And if you go to the next slide, there's also some kind of arbitrariness in this. Right, at this point, we could put in either community. The computer's not going to know what to do with it because it's equally and thinly connected to both of these. And so the reason I want to kind of sketch out how this empirical method works is to point out a couple of things. First of all, there's no presupposition about the constituent units, right? So we're not saying start in downtown Manhattan and start working out from there. Look at all the people who are flowing into downtown Manhattan. It doesn't even know which one of these points is downtown Manhattan or downtown LA or wherever. There's no assumptions about MSAs. There's no assumption about central labor market areas. It's just this complicated system of interactions woven together by commuter patterns. The second is that what the computer is looking for is cohesion rather than bigness. So we're not saying look for really large sets. We're not saying look for sets that have a lot of population. We're saying look for sets that are relatively and statistically surprisingly self-enclosed. And what you get out of that is as you maybe saw, actually, can you go all the way back to the US map? So the Upper Peninsula of Michigan probably not be considered a megaregion according to any a kind of normal definition of megaregion, but because it is fairly self-contained in terms of its commuter structure, there are not too many people coming or going within the structure of cities and towns in the Upper Peninsula of Michigan. Computer has found that to be a cohesive area. I'm going to show a couple of kind of regional scale illustrations of how this works, just to suggest some of the complicated ways in which this algorithmic process works. So in this case, I took just the commutes within the 6 states of New England. I figured you'd be kind of familiar to some of the people in this audience. In the presenter notes, I think this is counts for about 6 million commuters within that, people who are both living and working within those 6 states. And when you model the data in slightly different ways, you get slightly different regional outcomes from this modeling process. So here's just 2 model runs. You can see the emergence of similar phenomena, but for instance, in the left, Maine gets divided into 2 regions. On the right, it's mostly contiguous. If you go to the next slide, here's 2 other models. Again, you can see some differences between them. This is essentially just taking that commuter data and parsing it out in slightly different ways. In some of the cases, we include people who are living and working in the same census tract. In some cases, we don't. Other cases, we weight it according to margin of error. Other cases, we don't. If you go to the next slide, these are all 4 of those same model runs overlaid on top of each other. And what's interesting to note here is both some regional boundaries emerging over and over again as we ask the computer to do this on slightly different versions of the data. What I think is most interesting is where you see the emergence of political boundaries that are not kind of reflecting underlying physical geography, right? So the fact that we see a distinct Nantucket and Martha's Vineyard is not surprising. There are not too many people commuting in and out of those islands. They're at least a physically distinct unit. But the fact that we're able to pick out this Maine-New Hampshire border, which is arbitrary in many ways, there are many roads that actually kind of snake up and down that boundary, is suggesting something about how the regional structure of labor markets, about individuals' choices about where to work and where to live. And we also see both kind of some familiar political units and also the way that those familiar political units are non-functional. One of my favorites is this is essentially Worcester County right here, and it appears over and over and over again in the data. Again, the computer has no idea that those points are in Worcester County or even that they're near each other. But the fact that we see that across 4 different model runs is suggesting that there is something going on there in central Massachusetts. The fact that we see sort of northern New Hampshire being absorbed into a mostly Vermont sub-region in this analysis is suggesting something also about how those 2 states are connected or disconnected. So the reason I show this kind of mini example is first of all to suggest that we can use this same analysis in a scale-independent way. We can look at even a single city and parse out subregions within something like a single metropolitan area, or we can take a whole, about 4.5 million point-to-point connections within the whole contiguous 48 states. Is that the right number? I think it's like 4.1 million connections. You can do this same process at different scales. And so that kind of hard-edged map that Alasdair showed at the beginning, again, should not be interpreted like watersheds. A lot of people look at that and they think, oh wow, people are commuting from the edge of these areas to the middle and back again. That's not what we're seeing. What we're seeing are complexes of interrelated cities, small cities, rural areas, towns, that have some sort of meaningful economic cohesion with one another. And there's a lot of porosity between them. So what you see in this figure, these are our national megaregions, origins on this axis, destinations on that axis. If those really were watersheds, this diagonal would have all of the commutes. Everybody would be starting and ending in that same megaregion, right? So the brighter colors are more commuters. You can see we did a pretty good job because most of the commutes do stay within these regions that we derived empirically. This kind of cluster right here is Richmond, Raleigh, Charlotte, Knoxville, Louisville, Des Moines. That's a cluster of sort of interrelated regions where there's a lot of commuter flow, a relatively large amount of commuter flow between them. Saying this is that upper left corner is essentially the Northeast Corridor, Boston, Hartford, Albany, New York, Buffalo, Philly, Washington. You can see how bright those pixels are, which represents a fair amount of cross-regional flow. Again, cross-region, meaning these regions that we have algorithmically produced from the network structure. I think, is that all I've got? Yeah, so back
just following on, I won't say
Alasdair.
too much more because I don't want to steal anyone's time, but this map shows you the connections. It's like the original commute map, but the colours now represent the megaregions. And I think this is kind of a more useful one because it shows you, if you like zoom into Chicago, Indianapolis, Des Moines, it shows you the messiness and what I call cogginess. They're interlocking cogs in a way, and they bleed into each other. Not a huge amount, but that is probably a better representation of what this is like. They do work like this in reality, but I think this messiness and the bleeding colours is kind of a really important point, and it's hard to represent that. Drawing lines on maps is always a dangerous business anyway. But sometimes you draw fuzzy lines and fuzzy borders and people want hard borders, so we sort of present both in a way. I like making animated GIFs, but this emphasises it. This is long distance commutes in this sort of old megalopolis area. One dot is 5 or more people, and you can see what you already know. There's this interlocking relationship, and this represents huge amounts of stress and pain and human suffering as well. That's the misery of it all. But it looks quite nice when it's animated dots. But that's just a visual representation of it. And if any of these are you, thanks very much. The one thing we didn't do, I won't say too much more, but one thing we didn't do was we divided up the US in this way, but we didn't actually give any numbers. So this map is of mean income. So when you do this, you hope it makes sense, and it does make sense. We weren't able to get median, so it's mean, but Chesapeake, Manhattan, Quinnipiac, and Golden Gate, the highest, as you'd expect. And then you see Blue Ridge, Ouachita.
Yeah.
See, look, I'm just a foreigner. I'll work on that. So that's mean income, percent white. So if you look at the demographics here, the highest values are 88 to 93% in terms of percent white. That we kind of what you see, I suppose, is like interesting breakpoints here that kind of mirror historical patterns, which is quite interesting.
The one thing I'd point out about this that's interesting is, if we aggregate by things like states, you get states in the South that are covering both very white and very black regions of the country. Whereas if you aggregate by this Blue Ridge region around Knoxville is actually the whitest of our regions, interestingly, in the South. It's kind of counterintuitive. Would the whitest region be in the South? Turns out that it is, and that's a phenomenon that's masked when we're aggregating by more traditional political units like states. And you can see kind of similar patterns throughout the country.
Yeah.
So when you talk about income, it's personal family income.
Could you speak up, please?
Because that may affect, for instance, if you have two people working, two commuters, and
Yeah.
that
We
could be
used household
big-
household
This is
income.
household
Household income. Household income.
household.
Yeah. Yes.
And the reason
So
we had
they
to do
consider then the number of people commuting there in the family.
All of these statistics are not just for commuters. So we re-aggregated census statistics across these regions.
Yeah.
So we're not just MSA commuters.
Yeah.
This is essentially if the census were to
OD.
take these as units of aggregation
Yeah.
rather than MSAs or counties, right?
Yeah. And we did one. We just showed you one transit one. So
This is commuters.
this is the percent driving alone, right? And the lowest value is about 52.2%, and that's basically as you'd expect. Because why would you drive alone there?
For commutes?
Yeah, commutes. Yeah. And we get the highest values up to 84%, and that kind of maps on to what you might expect, but it does it using our boundaries. What we have done, like I said, we'll share the link with you. So we put some numbers. I won't go through these numbers now because there's not enough time. But we put the numbers in a couple of charts, and I think we will. This should be published as a book chapter.
Yeah.
We'll
We'll probably put the tables online.
Yeah, we'll put all the stuff online. So this year. So really, I'll let Garrett talk 2 more slides.
Yeah,
and then we're done.
I'll be really brief just in conclusion. As I said, I was a historian before I was a data scientist. And I've got a collection this thick of attempts to re-regionalize the United States that failed. This is just one. This is a geographer writing in 1934. So we're doing similar work to the work we did, obviously using more rudimentary empirical methods. But the outcomes are not that different. And to what end? The discernible practical and policy implications of papers like these have been relatively weak. And there are, again, scores of attempts to do this, to say that political geography has it wrong. We've looked at the functional or the economic geography of the country, and this is how we should be thinking about it in terms of national economic planning, regional transit planning, and so on. And so close with kind of a provocation to think about how we move from an empirical and analytical description of these regions. Alasdair and I crunching a giant data set on an Amazon supercomputer and saying, aha, we've got it. This is what the United States looks like. And moving to a kind of political and social question about how to transform institutions, how to transform ordinary people's sense of community identification, rather than telling people you suddenly belong to Regional Planning District 5, which is not something that is very easy to build a kind of democratic legitimacy around. How do you convince people, voters, ratepayers, electoral politicians, that these are meaningful geographies of collective action? I think that's a much more difficult question in some ways. But I will say that it is one that I think has a relationship to some of these empirical and descriptive techniques. You're welcome to explore it at some point. We'll give you the link. We did this interactive version of this Megaregions map, which went around this kind of traveling exhibit, where people can actually zoom in on their individual, where they're from or places that they care about, and see how that place is connected to different parts of the country through this commuter structure. Hopefully, with the goal of, essentially making people think differently about the regional geography of the United States. And how do we build on top of that the institutions, the kind of practical policy-making apparatus that would match it?
Good morning again. Thank you, Armando and Bob, for this opportunity for me to share some of the recent work my assistants and my colleagues and myself have been doing recently, focusing on the Texas Triangle. Here, I call it 5 dimensions of the megaregional process, in a way that not necessarily looking at the megaregion as a state, the current condition, but rather as a process. Look at during the process and what's happening in terms of people's movement in the geography, in this large geography. A little bit of background, Armando, can you recognize yourself? 2006, we started working on Texas Triangle megaregion with help from RPA Lincoln, of course. And at that time, various discussions or debates regarding whether or not Texas Triangle qualified as a megaregion. And some say, well, there's one, there are two, there are three, or there are none. So quite a debate. And then my bosses, Fritz Steiner, now Dean at the Penn, and then associated Ken Butler. Unfortunately, he passed away. And then we wrote a paper about this. Texas Triangle is a geometric coincidence or is an integrated megaregion? So the question raised and then did not find a solution at that time. Well, instead of trying to find a solution to argue whether or not Texas Triangle is or is not, let's look at the information and the data we have had in the past 12 years. Right? The 12 years have gone by, and let's look at the data. Currently, we compiled information or data, and then I put in this what I call 5 dimensions that may help characterize megaregion as a process. What I call interactively agglomerating and network flowing. There might be some kind of an English grammar challenge over here, network flowing, put it this way. And territorial resorting and competitive co-producing in the finally identity forming. It's kind of our conceptual framework. So first one, agglomeration. We talk about regions, right? We cannot avoid talking about agglomeration. Here, but look at the Texas Triangle. Census data say dated back to 1900. Sorry. Population density at the county level. So look at this higher concentration or agglomerating in 2 counties in Dallas area, and then 10 years, and then Bexar County near Houston, not yet Houston area, Houston, 40. 50 along the corridor, 70, 80. This is a trend of agglomerating, of course, but not agglomerating just by the individual metropolitan areas independently, but they are attracting with each other, particularly along the currently I-35 corridor, for example. Look at this 1990 and 2000 and 2010. And then look at the population projections. The triangle continues to agglomerating, but with some kind of directions. Directional, that's what I call it. 40 and 50. And then current evidence, well, many years ago, several decades ago, Dallas-Fort Worth were 2 separate communities. Now one integrated metropolitan area. San Antonio, Austin, there were 2 separate cities and separate metropolitan areas. Look at the census. The most recent census shows that the 2 are already connected. So this is kind of the population agglomerating trend. It's the first dimension. Flowing, look at the flow data. The freight by truck, by different types of community. Different types of community, similar to different industries. They have different ways of interactions here, and depending on the locations and where the different types of firms are located. So here, without going into the detail, pointer at different types like this machinery center in Dallas area. We were surprised. In Austin, quite a strong machinery movement between Austin and the Dallas area. Raw materials, petroleum, Houston-based, of course, because of the port. But look, these miscellaneous goods, the triangle pattern, very strong. I'm not talking about the lines. Width of the lines indicates the intensity, the density, how much tonnage, how many tons per mile. Look at the air passengers. When we work on the ground transportation, rarely we look at the air flows. Look at the air passenger density. Number of people, passengers per mile. So total flows divided by the distance. Here, this one we did 2006, and then look at the 2010 data, 2015. It's kind of a spatial pattern corresponding to the RPA 2050 pattern quite strongly. Yeah. Close? Yeah.
Yeah, that helps.
And then, again, I think about that as a process instead of as an end state. Because megaregions evolving, not all the megaregions are in the same state, same condition here. And look at the super commuting. Aside from looking at the commuting within metropolitan area, look at the super one. Distance longer than 50 miles, or travel time longer than 90 minutes. 1990, these people are traveling, people are driving, Texans driving all over the places. Well, you see the within metropolitan area, commuting, of course, is strong, but to put it in a short way, 2000, 2010, 2015, you see kind of this increasing super commuting among the metropolitan areas. The absolute amount of commuting volumes still been low, a small percentage, 3 to 5% nationwide, but it's one of the fastest growing sector in terms of commuting. Territorial resorting movement within the triangle area. We look at the migration. People moved around during the census counting years. Here, the general background in the U.S. is that after 1970s, people are less likely to move. They're still moving. In other words, current generations are not as likely to move as their parents or grandparents, meaning that they're kind of like trying to stay in the places. Some researchers suggesting this kind of a trend of localism, new localism. So look, with that background, let's look at the Texas. Texas migration patterns between 2011 and 2015, 17% movers within that time frame. Some moved from one county to another within metropolitan area, moving from out of state and moving from out of country, of course. And then here, migrations moving within metropolitan areas. The trend similar to the national. So within metropolitan areas, people tend to move from core counties to suburban counties. There are also counterflows, moving from suburban counties to core counties. Well, the percentage of the flow is relatively small. So with this background, and then within metropolitan area, like within the state, county to county, this is something, movement, migration among metro areas within the triangle. And they move, but they tend to move within the triangle area. And so I observed this. There's a kind of a strong triangle adherence in this movement. And also interesting that most this inter-metro movement or those middle to higher income households. So this is the second dimension. We'll continue to look into this community of migration and trends, and then the different demographic groups, their migrating characteristics. Competitive co-producing, that's kind of like textbook-based economic analysis. Look at the economic base of the metro area, so whether or not different metros, they compete or they complement in terms of the sectors they specialize. This is work done in 2004 based on one economics from Federal Reserve in Dallas. So we followed that kind of approach and came up with our analysis. Look at here, how many sectors that the 4 metro areas all specialized in. If they're all specialized in, meaning that they kind of competing with each other. And if not many, then in the sense they complement with each other. Here, oil, gas extraction, transportation services, there were 3 metro areas out of 4 major metro areas in the triangle. They all specialized in those sectors, and electronic and other electrical equipment, Austin and Dallas. So, pretty simple way here, I use numbers to indicate how many metros specialize in that same sector. So, in this case, 3, 2, 2, 2, and transportation by air, right? 2 major airlines, American and Continental, based in Dallas versus Houston. They compete with each other, but they have their own kind of market shares, sub-market. Look at the 2016 data, kind of a decreasing in terms of competition in those sectors, oil and gas extraction. For all of those metros specialized in real estate, heavy construction, eating and drinking, that's more kind of a local services. Texas Triangle, I guess they provide way more eat and drinking places than they can consume locally in a sense. So just ignore those local services sectors, look at those. So there is a trend that there's a co-producing and shifting in industries, industrial specialization. And of course, the evidence is still not strong enough. We keep exploring, particularly looking at the even lower, more detailed level of industrial classification. It may vary depending on the 4-digit level, 5-digit level industrial classification for this kind of analysis. Finally, megaregion, I think we talk about a region, a culture, and identity. Talking about south of England, London area, northeastern corridor, there is a kind of a culture, a sense of identity over there. Northern powerhouse, right, the north, the non-transportation aspect. In the Texas Triangle, there may be a strong Texan identity, but not necessarily the triangle itself that distinguish the triangle from the rest. So look at some kind of anecdotal here. Explore the history of Texas Triangle as a term, as an expression. Actually, it came up first in 1936, describing rail services. What a coincidence! Rail services serving by MOPAC serving the Triangle area. And then now to talk about the Texas Triangle, probably talk about NBA. There are 3 major teams that you need to conquer before you can become a national champion. So the culture part, I think, still either exists or does not exist. But I think it's important to look at the identity, the culture aspect that distinguish an area, whether or not it's a region. Yeah, some implications of this preliminary. Actually, those implications in a way answer the questions raised earlier, what megaregions are good for. Here, in terms of functions and services, think about megaregion, a shrink space. Megaregion large in space, geography, but because of the new technologies, high-speed rail and telecommunications technology and other applications, the time space probably remains the same as a metropolitan area. And then people's commuting behavior changes. So it will expand access to opportunities for people in the area, in the geography. And behavioral sense, Foster kind of touched upon that. Why not conventional transportation planning framework is based on daily commute. Nowadays, people make decisions not necessarily just on a daily activity demand, but on a weekly, for example. They just go to work 3 days a week, and then the kind of a mode choice behavior, for example, will be different from others who have to commute physically every day. So it's like a daily commute versus weekly commute. Lots of new ways to collect data and a new analytical framework. And spatial inequality trends here, in the megaregion scale, when we talk about spatial inequality, there's a classic geographic challenges, right? Modifiable urban area unit problem. Measuring that, when you look at the same data, aggregate into different levels, you come up with different solutions, different challenges. So analytically, there are issues we need to deal with on spatial inequality, infrastructure investment. I think megaregion thinking, very important, is long-term thinking. Think about 30 years, 40 years down the road, and what we can or we should do now strategically so that we can accommodate the challenges coming in the next 4 or 5 decades. Institutional, raised earlier, very challenging MPOs, currently responsible for transportation plan, for metropolitan areas in the US, but many challenges are beyond their jurisdictional responsibilities. Final comment, remark to megaregion supercity, that's in the context there. Well, I think it's a shared phenomenon in the global urbanization trend, and megaregions in different countries, they develop right now in different stages, so it's important to look at as a process. I talked about that already. Finally, maybe allow me to do a little commercial. Here we have a center in Texas. Austin Penn is a partner. We have 4 partners supported by US DOT. It's specifically looking into mega-regional transportation issues. Thanks to James, and from the federal. And then James also organized last year, about a year ago, in Texas Triangle Mega Region. Oh, they don't allow. Oh, now it's okay. Yes. Now it's okay to say mega region. And at that time, it's about multi-jurisdictional regional issues, because the mega region term came from the previous administration, and organized a Texas version mega region workshop nationwide. So we do here. This is our kind of partners from 4 researchers from 4 university 4 institutions, and so far we have done support more than 50 projects, and working on the institutional challenges, inequality issues, and then modeling and applications of new technologies. So another commercial, I'm currently editing a special issue in Transportation and Research Part D, particularly looking at transportation and environment issue at this larger scale. So I'd appreciate it if you could contribute a piece to this journal. It's due August 15th, so still we have time. Thank you so much for this.